In this video, I'm going to provide an insight into descriptive statistics and give some guidance on how you might choose between some of the options that are available to you. The video is a progression from the base decisions video that's been previously posted, so I will rely on some knowledge of the terms and the flowcharts that have been previously introduced. If you've not seen those, then I encourage you to go back and view that video before returning to this video. The focus of this video is on central tendency and dispersion. I'm going to introduce key terms and make sure that you're perfectly happy with what those words mean. Progress on to the flowcharts or decision trees so that we can start to look at how we'll decide between our options. And then I'm going to give some examples of how to do these analyses using both Microsoft Excel and JASP. The first terms we need to be sure we're clear on are exactly what central tendency itself means. And when you get data, you tend to find that it clusters towards a few specific values. And so we have central tendency statistics to represent what those values are. These are the mode, the median, and the mean. You may well already be familiar with these. If not, there will be a brief recap shortly. Dispersion is another key term that we need to make sure we understand. And this is a representation of how similar or different our data is, typically in relation to a measure of central tendency. Other terms that you may hear referred to as stretch and squeeze of the data, variation or variability, but this is not to be confused with variance, which is a statistical measure in its own right, or potentially the spread of the data. Another key concept is the difference between sample data and population data. If we have all of the information that's possible, so for example we tested every person in a population, then we would have a vast sample size. Imagine if you had the data for every person in a country, for example, and that would be very time consuming and very expensive. So it's very unlikely that that sort of study will really go ahead. What we tend to do is identify a suitable number of people to get the information that we need, and we test that. And that's what we refer to as a sample. Now this concept's important because when you start to look at how some of the statistics are calculated, there'll be an option between whether this is a sample or whether this is a population. And there's a very subtle difference, and we refer to this as the Bessel correction. So quite often you'll see something divided by n, and this means divided by the number of data points that you have in your sample. If we have a sample instead of a population, then we have what's considered as one less degree of freedom. We don't have the full data set, and so we divide by n-1 instead of n. And remember, this is only important if you're doing a sample analysis rather than a population analysis. But because in the vast instances then we are doing samples, then you need to have an understanding of this process. If we were looking at some sort of application when we might need central tendency, the sort of question you might be asking would be, what's the typical value for? What value best represents? And what's the most common? Anytime you hear anything like this, what's the typical wage in this area? What's the typical height of this person? What's the typical heart rate of another? Then what we're looking at is a number that gives us an idea of what's most common or what we might encounter. And so this is where we come back to the mode, which is the most commonly occurring number. And when you think of it this way, you may ask yourself why we don't hear mode more often. But it's a very specific value. It's a number that needs to be exactly the same. And often we have numbers that are a few decimal places differently, and it starts to get more difficult to acquire this number. The median is the number where if we take all of the data we have available and we arrange it from smallest to largest, the number that's in the very middle is going to be our median number. And this requires the total number of data that we have to be an odd number. So for example, if you consider here, if I have the numbers 1 to 7, then the number 4 has 3 numbers smaller than it and 3 numbers larger than it. And so it's very easy to spot that and calculate it. In the instance that you have an even number, then what we need to do is take the 2 numbers in the middle, and then we add those together and divide it by 2. The final option is the mean or the average number. And this is represented by the sum of all of the numbers divided by the total number. And this is a number that we hear in everyday language. So we're very comfortable saying, oh, what's the average anything that we might be talking about? And so it's nice just to actually see that equation in there to remember how we would go about acquiring it. I'm just going to switch over to Microsoft Excel and we'll just have a look at how we can get any of these values then. I've got two lists of numbers here equal to what we've just seen in the PowerPoint slides. And if you remember from previous videos, or if you're already familiar with Microsoft Excel, you'll know that to get Microsoft Excel to do anything, first thing we need to do is type in the equal sign. If we're going for the median, we can just type in the word median and then select all of the numbers in our column here, hit enter, and you can see that we get 3.5, which is the same as what we saw in the slide. The bottom right hand corner allows us to drag and copy the equation. Now if I copy this across, the first thing you notice, this is the same, whereas the previous information indicated that this should be 4. And a nice little error checking process you can do in Microsoft Excel is to come up to the command bar here, this formula bar, and if I click here, it highlights and illustrates what information is being used in this command, this formula. And we can see that because this is just copied across, it only thinks it has 6 numbers. So if I increase the size and then hit enter to get that, then we can see that there's an immediate update which gives us the same number that we've had before, which is the correct median. If I was looking for the mean value, then Excel actually uses average. So I type in average, collect all of those cells, make sure they're highlighted, hit enter, and then same process as before. Now often you'll find that the mean and the median are very similar to each other. In a normally distributed data set, they will be exactly the same as each other. And what you find is that the further your dataset travels away from a normal distribution, the greater the difference between the mean and the median will be. I will be producing another video on data distributions when we'll look at things like skewness and the influence on measures of central tendency, so I'm not going to stay on that now. The mode is the only measure of central tendency we've not looked at here, and if I was to put that in, simple command once again, just looking at the word, open brackets, and then enter your array, and you'll see that we don't get any numbers in here because there are no repeating numbers. If I create a new data set here and I use number 1 repeatedly, then I copy down the formula, or copy across the formula I should say, you can see that this allows us to get a result from this mode command. The need for an exact replication of a number is a limitation of mode, and this is one of the reasons why we don't see this used more frequently in statistical analysis or reports. Return back to PowerPoint. This is the flow chart. For those of you that have seen the previous videos, you should recognize the top portion of the flow chart, and you can see the initial decisions are exactly the same. We always start by considering whether the data is lower order or higher order. Back to our scales of measurement, we always consider whether higher order data is distributed normally. Now, one thing you'll notice is that if we work from nominal across to the right, then the mode is available to all options. And what you find is that with each move to the right, then you gain more options. And this is another instance where I'd like to remind you that when you get higher order normally distributed data, it doesn't mean you have to use certain options. It means you have the ability to use whatever you want. And people tend to use things like the mean or the average because that is what most people are most comfortable with. That doesn't mean to say you shouldn't use the median or the mode. Let's have a look at dispersion. So the type of questions you might hear that dispersion can answer are how reliable is, how consistent is, or what's the range around. And these are very important points because what we're starting to look at now is if we repeatedly do something and we measure this process, are we going to get the same type of numbers? If we have got a number, someone's given us a value and it has a very small dispersion, then we can be confident that that's going to be a number that we can rely on. If there is a very large dispersion around a measure of central tendency, then we have to accept that we might be getting a bit of a difference in the numbers if we repeatedly complete the same process. The typical measures for dispersion are percentages, fractions, interquartile range, and median absolute deviation, or probably the most commonly, standard deviation. Just have a look at some of those. Percentages, I'm guessing most people are comfortable with percentages. We are just looking at a portion of a total. And in many ways, they're very similar to how we would consider fractions. These are really useful, particularly if you're dealing with something like nominal data. So if you were looking at the prevalence of a particular condition in a geographical area, it's very useful to say, well, how many of the people in that area, what percentage of the population have this condition? Likewise, if you're working with a particular patient group and you were looking at how well they respond to a particular medication, it's very useful to know what percentage of these population are responding well. The interquartile range is a very common non-parametric measure of dispersion. If you imagine that a simple data set, I'm going to take an example of the numbers 1 to 12. For the interquartile range, we simply split these into quarters, and then we look at the difference between the first quarter and the third quarter. So if I look at this logically here, we can see that 9 is at the top of the third quarter and 3 is at the top of the first quarter. Subtract the 2 and we have 6. I would just like to put a little caveat in here though, that if you're using software to calculate values such as the interquartile range or even just an individual quartile, they are not consistently calculated the same way. So you'll often expect 6 and the answer will be 5.5. If anybody is particularly interested in the different ways in which software like Microsoft Excel and JASP calculate these, I will put them in a separate video. But for the sake of keeping this video relatively short, I'm not going to dwell too much on the exact process now. The decision tree for dispersion, very, very similar to that for central tendency. Again, nominal has only one option where you can look at this percent of the total fraction, and again that could be presented as a fraction around it, but typically a percentage is more commonly offered. When we get to ordinal, then we can have median absolute deviations or interquartile ranges, and standard deviations should only be used for higher order data that's normally distributed. Now this is a largely overlooked concept. It's incredibly common to look at data, and even if the authors acknowledge that the data is not normally distributed, so they will do non-parametric inferential statistics, they still use mean and standard deviation, and this shouldn't happen. In the instance when you have data that's not normally distributed, you should revert back to medians and median absolute deviation or interquartile ranges. I'm going to swap over to Microsoft Excel. We'll have a look at some of these options. Then we'll go back to JASP and have a look at the results that we get from there. Now I've pulled in a data set once again from Mark Goss-Sampson's book. It's a file called Exploring Data, and you can see that we have 2 groups and each group has 3 variables measured. I'm going to go in a similar process to what we did before, and I'm going to start by looking at the median. Then we'll present the mean. We'll have a look at the interquartile range, the median absolute deviation and the standard deviation. Then we'll get the same values in JASP and just look at them side by side to ensure we're getting the same thing. The median, as we've already seen, we can just type median, and for the sake of allowing me to drag across without having to correct later on, I'm just going to start a little bit lower than the actual array of data finishes, because it allows me to drag that across nice and quickly. And this is one of the real advantages of using Microsoft Excel. It allows you to get this information very, very quickly. If you remember, the formula for mean is actually the word average. And for this, same process, drag. I need to start a little bit lower. And then we've ended up with a few decimal places here, so I'm just going to use the decrease decimal places just down to 2 decimal places to make those numbers a little bit more palatable. So they're nice and easy. We can just do those with simple commands. But remember, the interquartile range, we need to look at the difference between the third and the first quartile. Now there is a command, quartile, and I'm going to use that, and I'm going to put a comma telling that I want the third, and rather than doing things separately, I'm going to combine these into one single process. So I'll get the third and the first, and I'll tell Excel to subtract those, which gives us the interquartile range. Nothing too challenging so far. Now the median absolute deviation, there is no command for in Excel, so there's a couple of ways in which we can go about this. Now we already have the median value, so to get the absolute deviations, then I could say I want the absolute value of the difference between each individual data point and the median. So I've said I want the absolute value. I want to make sure that it never shows me any negative numbers, only positive numbers. And I want the difference between each individual data point and the median. Now, if I was to hit enter now and then try and drag this down using that little marker in the bottom right hand corner, then what you'd find is that both the variable would change and the box looking for the median would change. So I'm just going to hit F4 on the keyboard and you'll see these dollar signs appear now, and this tells Excel that even though this blue box can move down the line, this red box will never move from the median. So now if I bring this down, we get all of these values, and if I select the bottom value, then you can see that the blue box has followed down the list, but the red stayed locked on thanks to those dollar signs. Now option 1 to calculate the median absolute deviation is now to get the median of this list of absolute deviations. So you see step 1 was to calculate the median, step 2 was to calculate the difference between each individual data point and the median, that was the deviations, and then the absolute value was making sure that I don't have any negative numbers. So the final step is to calculate the median of all of these. Now, if I was to do this for each of these variables, that means I'd have to create 6 new columns. And there is actually another way in which we can do this. If we tell Excel we want this to be treated as an array, and people tend to be a little bit more dubious about using arrays, so we'll just go through this slowly. Now remember, what we're looking at is a median absolute deviation. So we need a median as a starting point. And then we need it to be absolute, so no zeros. And we're going to need a couple of brackets there. Now this is our data set, and we need that to be different from the median of these. So now I'm going to put the median of our array. I'll put this back in. Now the trick at this point, if you want Excel to treat this range of numbers as an array, is you need to do Control Shift and then hit enter, and you'll notice now these little curly brackets appeared at the end and start of our formula. Now at any point now, if I click back in this command and then this formula bar, and then I hit enter and I forget to do the Control and Shift, then those will often delete and then they won't update. So anytime you go back in here, do remember to Control Shift delete. And you can see that now I don't need this column of data over here at all. I can delete this, and my number, which is, we've proved our longhand process, this is what we're looking for, our number stays the same. And of course this gives me the option now to just drag across. So the final thing that we need to look at is the standard deviation, and this is a simple ST. If I do this, and you see you get numbers, as soon as you start to put in a formula, Excel looks for things that it thinks it might be, and we're looking for this standard deviation. You can see that we have standard deviation for a population, for a sample, and then including logical values and text. We're not going to worry about those for now. If you remember from the earlier part of this video, we're looking for a sample, so we will select the version that's .s. I double click there. I can get my range, and of course I can then minimize the decimal places down to 2 for consistency, and I can drag across. So here we have our range of numbers. I'm going to pull up JASP now, and you can see that I've actually already loaded these in. they have to be in a slightly different format. If you notice, even though in Excel I've done these side by side so we can see these, in JASP these need to be on top of each other. So group 1 at the top, group 2 underneath. I've pulled the descriptive statistics in and listed the variables, and then in Form JSP the group tells it where to split. And then you can see here that we have our same click options that we've had before. So top of our list we have medians, and you can see here 876, 876, then into variable 2 come across 5175, 5175, and variable 3 0565. Okay, and 0.76. So these are marrying up. Remember that they are organized variable 1 in group 1, group 2, so they're staggered across. You have to sort of jump backwards and forwards, but I'll let you pause the video and look at that in your own time. If I bring in the mean value, then you can see that we have 874, 5141, 874, 514, and as close to 1 as, damn it, if I'd increased the decimal places it would have stayed there. In group 2 we have 837, 491 and 0.8, and then over here with 837, 491 and 0.8. Interquartile range, you can see once again matching up. I will pull in median absolute deviation and the standard deviation, and you can see here that even though there's only one option for standard deviation in JASP, that it is assuming that you are working with a sample. Obviously much quicker in JASP, but you don't get the mechanics of what's happening in the background, so I think it's worthwhile exploring with Excel just to ensure you're confident with those processes. If there is any aspects that you'd like to learn more about, please do put comments, leaving requests for future videos, and I will see what I can do.